So I will start by explaining why certification is needed. Basically, the idea of certification is to level the playing field, is to allow to all, let's say, manufacturers to play with the same rule on the market and to provide a fair competition to the market. The idea is to provide a fair comparison using a standard benchmark, meaning standard testing methods and standard rating methods in order to increase the consumer confidence. This ensures that a performance before purchase. This eliminates, for example, oversizing due to underperforming uncertainty. It eliminates expensive customer verification tests. The tests are done under the certification scheme, and this avoids also excessive system operating costs. If you can go to the next slide, please. So in a nutshell, the certification aim is to build confidence. The objective is to de-risk all the process. It reduces the risk of inefficient and unsafe ventilation systems. It guarantees the energy efficiency of the complete system, and it avoids performance downgrade due to the use of non-certified spares during the maintenance. And all of this scheme is done under the ISO 17065 standard, which is a standard for certification bodies. And this is checked by an accreditation body, which is independent. And all of this scheme is recognized internationally through different international recognitions. Next slide, please. So first, we can see how Eurovent certification has been dealing with ventilation systems and components during the past years. Eurovent certification is working on ventilation for more than 20 years. As you can see, the first certification program was created in 1998 for air handling units for the complete system. And you see that over the years, different components in the HU have been introduced as dedicated certification programs, including air filters, which has been created, for which the program has been created in 2006. And the first certificates were available, I think, in 2007. So this was a key milestone in this journey. You see that we have dealt with heat exchangers, plate and rotary, runaround coils, ducts, and fans. And recently, we also added a program for hygienic handling units. And in 2020, we improved our energy efficiency rating for handling units, adding the efficiency in hot and humid climates. So from this slide, you can see that we have a complete holistic approach regarding certification of the ventilation system and all the components in the system. Next slide, please. So regarding the energy efficiency, the background is the Eurovent work on energy efficiency for air filters. Eurovent Association has been the first organization in the world to propose a method for rating the energy efficiency of air filters, and this has been done since 2013. So really, Eurovent Association was well in advance in the world in this area. Today, the latest document to describe how to rate the energy efficiency of an air filter is Eurovent 421, which is dated 2019, and explains how to compute the energy consumption, the assumed energy consumption of an air filter. And of course, this method can be used and is to be used together with ISO 16890, and I will explain later on how the connections can be done with the two documents. Next slide, please. So the principle is quite simple. An air filter is not, let's say, inducing directly an energy efficiency. It's a passive element, but it causes energy consumption due to its pressure drops over all over its lifetime. So basically, the energy efficiency of an air filter can be computed based on its average pressure drop, which is shown here in this formula with delta P. And the energy efficiency, W, can be computed by assuming some basic values in terms of nominal airflows. Here you can see the standard airflow used is 3,400 cubic meter per hour. An average operation time, which here is assumed to be 6,000 hours per year, and an average fan efficiency, which is 0.5. From these assumptions, we can compute an energy efficiency based on the average pressure drop of an air filter. And the below formula shows the numerical application of this formula. The energy consumption kilowatt per annum is derived from the pressure drop in pascals. Next slide, please. So how should we rate the energy efficiency of an air filter? The testing method is as follows. You have to carry out first the ISO 16890-1 tests for a full-size air filter. Then you have to load the filter with AC fan dust according to the ISO standard 16890-3. It's the standard belonging to the same series as the -1. And this load has to be done until the amount of dust defined in this table has been reached. So for EPM1 filter, you have to load 200 grams. For PM2.5, 250 grams, and PM10, 400 grams. Then from this load, you have to calculate the average pressure drop through all this process, and then you can calculate the yearly energy consumption, W. Next slide, please. So this is what I just explained is the principle described in the Eurovent association document. Then from this value in kilowatt-hour per annum, the Eurovent SATITA certification reference document is defining in which energy class the filter has to go from this energy consumption in kilowatt-hour per annum. What you can see here are the correspondence tables where you can see that for EPM1 on the left, EPM10 on the upright, and EPM 2.5 on the below table, you can see from the efficiency, which is seen on the left side, you can compute the energy classes based on the result of the energy efficiency in kilowatt-hour per annum. As PK explained earlier, you can see that, for example, for EPM1, the best class is for air filters consuming less than 800 kilowatt-hour per annum, whereas the lowest class corresponds to more than 2,000 kilowatt-hour per annum. So it's more than the double difference between a very efficient filter and a not efficient filter. So this may have a big impact overall in the system if you take it into account. And what is very important here and to see on those tables is that the energy classes and the rules to define the energy classes are always based on first the filter efficiency class. So it means that not all filters can be rated the same way because EPM1 have a function of filtering very efficiently the air, whereas EPM10 have less efficiency. So it's very important to have different rules from those different type of filters in order to assess the energy efficiency. And here you can see on the right side the label which shows all the information related to this energy efficiency for an air filter. Next slide, please. So today we have more than 27 brands that are certified, representing more than 2,000 air filters certified. Filters that are certified are always at standard sizes, but it means that the one with other sizes can also be considered as certified. And from those 2,000 filters, you can see that there is a very few amount that reach A+. This means that the requirements to become an A+ filter in terms of energy efficiency is very high. Same for A and B. So these tables can show you what could be your, let's say, your target in terms of energy efficiency based on what the market can propose today. So if you look for a B-class filter, you know that you are looking for the top, let's say 25-30% of the air filters. If you are looking for A-class filter, it's around the top 12% of the air filters. So you can use this table to let's say define what is your requirement in terms of energy efficiency. And on the right side, you see an example for EPM1 filter, the distribution of the different air filters in terms of energy classes, A+ to E, and the filter efficiency from EPM1 50% to EPM1 90%. Next slide, please. So the conclusion is related to what has been discussed before, is that first you have to define your target filter efficiency. It's very important to not skip this this step. You shall not define first an energy or an energy consumption. The first purpose of an air filter is to remove dust from the air. So the first step is to target the filter efficiency. First the group EPM1, 2.5 and 10, and it was explained during the previous presentation how this can be achieved. And then you can define the value of the efficiency in percentage, again, as it was discussed before. Then the next step is to define what is your target energy efficiency class from A+ to E. And then you can find what are the relevant filters that could be interesting. And for this, you can use the Eurovent certification website by choosing the air filter that fits to your purpose in terms of filter efficiency and energy efficiency. Next slide, please. So thank you very much for listening to this presentation. You have here my email address, and of course you can send any question after this presentation if you have some. Thank you very much.